Some reaction setups seem very complicated, but most reactions are simple variations of the reflux apparatus.
Adding pieces of glassware adapts the apparatus for a slow addition of a reagent, inert or anhydrous reaction conditions, or for the removal of unwanted gas. Let's watch as the stagehands demonstrate.
Sometimes it is necessary to gradually add one or more reagents to the reaction mixture over a period of time. This is done by inserting a Claisen adapter between the round bottom flask and the condenser. The Claisen adapter is clamped in place, and the condenser is placed on the side arm of the adapter. The pressure equalizing funnel is placed directly above the flask. You need a condenser in case the reaction starts to boil due to heat released when the reagents are mixed, or in case you simply need to reflux during the addition. Reagent is added to the dropping funnel with the help of a long stem glass funnel. Then, the dropping funnel is stoppered. The reagent in the dropping funnel is added to the reaction flask by slowly opening the stopcock to allow a drop-wise flow of reagent from the funnel to the flask. The problem of protecting a reaction mixture from moisture is a common one for the organic chemist. Moisture can be excluded by adding a drying tube to the apparatus. Anhydrous calcium sulfate with or without indicator or calcium chloride are commonly used. The drying tube is prepared by placing a very loose plug of glass wool at the bottom of the tube and filling the tube with the granular drying agent. Cap the tube with a loose plug of glass wool to prevent the drying agent from falling out of it. An empty reflux apparatus is assembled and the prepared drying tube is placed on top of the condenser. Moisture is driven out using a heat gun. Start at the bottom and work up. Remember, do not turn on the water yet. Besides making the procedure ineffective, the apparatus may break. Once the moisture is removed, the hot apparatus is cooled to room temperature. The reagents are added quickly, and the reaction is carried out as described. Some organic reactions release noxious gases. This problem can be solved when relatively small volumes of water-soluble gases are released by passing the gas through water. A mini fume hood is made by attaching a hose to a long stem funnel and clamping it inverted over the apparatus with the hose running to the water aspirator. The vacuum sucks undesirable gases into the aspirator as the air passes the top of the condenser. Alternatively, you can make a gas takeoff adapter using the vacuum adapter. Use glass wool and a loose packing of drying agent to prepare the tube in a manner similar to preparing the drying tube. Apply gentle vacuum by turning on the water aspirator. Any gas formed by the reaction is removed by the dry air passing through the gas takeoff adapter. It is important to only use a weak vacuum or your solvent may be drawn off as well. Reactions involving air-sensitive chemicals need an inert atmosphere. In an undergraduate laboratory, reactions can be kept under inert atmosphere using a balloon filled with an inert gas such as nitrogen or argon. Generally, argon is the preferred gas when using the balloon technique because it is more dense than air and will fill the reaction flask, pushing out any air more effectively than nitrogen. To do this, either use a syringe needle or a three-way stopcock. To use the syringe needle method, fill the balloon with the inert gas from a cylinder, then firmly attach it to a needle and insert it into the reaction vessel through a rubber septum. With the three-way stopcock, attach the balloon, then check the different positions of the stopcock. Connect the three-way stopcock to the inert gas cylinder. Fill the balloon with the inert gas, taking care to ensure that there are no leaks. The stopcock with balloon attachment is then inserted in a flask. The flask is connected to a vacuum line through a two-way stopcock. The apparatus is purged by opening, then closing the stopcock connected to the vacuum line, then filled with the inert gas by opening the stopcock to the balloon. If the reaction is to be heated, a condenser will be needed. In this case, the balloon should be placed at the top of the condenser to prevent volatilized liquids from reaching it. Several organic transformations involve an overall dehydration step. Such reactions are reversible, and product yield is dependent on driving the reaction equilibrium towards products by removing water from the reaction mixture as it is formed. One simple way to do this is to use a dehydrating agent in the reaction flask. A more reliable way is to use a Dean and Stark trap. The apparatus is assembled by inserting the Dean and Stark trap between the reaction flask and the condenser. The reaction is conducted in a low-density immiscible organic solvent such as toluene, which forms an azeotrope with water. When the mixture is heated under reflux, the solvent water azeotrope volatilizes and, on condensing, is collected in the trap. The water separates and the light organic solvent flows back into the reaction flask. It is usually easy to monitor the progress of this type of reaction by recording the volume of water produced, or by waiting until the characteristically milky azeotrope is no longer formed.